Hello everyone, we are Virtual Engineeria, and today I'm going to show you a final project we completed for a client. And he is training his team on static compensators. And I'm going to show you a bit of the results of our work. So everyone, here I have the supervisory system that was developed. For this substation, this is identical to the real thing. So we are in a substation where there is static compensation. So I'm going to come over here and show you the single line diagram of the static compensation. So here it is, out in the field. We have the static compensator. But due to contract confidentiality, we won't be showing the compensation equipment in this video. So here it is, everyone. What is static compensation all about? The static compensator, which is this whole assembly here, is a piece of equipment whose function is to keep the voltage at the bus bar at a certain predetermined value. In other words, we set a set point and it will maintain the voltage. It also has another control mode, which is the reactive power control mode. That is, I set a reactive power set point and it will aim for that value. And the voltage at the bus bar will vary. Based on the system and not on the compensator's reactive power, because it will keep the reactive power fixed. The most commonly used mode is definitely voltage control, which is exactly what I'm going to show today. So here it is. The static compensator is at 20.05 kilovolts, and at the bus bar, we have 531.52 kilovolts. That's probably the set point value, 531, 532. Guys, static compensation, it has these elements, TSC, which is a capacitor, TCR, which is a switched reactor, just like. So we have two TCRs. So this static compensator is made up of two TSCs, this one and this one here, and two reactors that are switched. Guys, there are also the filters. The specialized electronic filters located right here are designed for managing any unwanted electrical harmonics. And now guys, look at this. Take a good look. The system has a voltage that requires compensation, and at this moment, it needs to bring in reactors. So it activated both reactors with 2,700 amperes in each one. Why is the current so high? Because the voltage is lower, 20 kilovolts. If I set a set point to lower the voltage, what will it do? It will need more reactor. So it will activate, it will try to increase the current. From the switched reactors, meaning there are thyristors there that have a firing delay. The greater the delay, the higher the reactive power. Inductive, that is current lagging behind the voltage. So here's what I'm going to do. I'm going to set a lower voltage set point here. I'll set it to 525 so we can see what happens. Sending the set point to my equipment and look, it starts. It reached 530. Increased the current and hit the maximum, folks. It reached the maximum. Alright, please take a look at this. TCR1, the absolute maximum threshold limit. TCR2, the designated safety limit. Both capacitors are off and my reactors are at their maximum current. Now, I'm going to set a higher set point, folks. Going to raise the voltage. I'll go to 545. That's a very high voltage, folks. It's a very high voltage. I'm almost 10% above nominal. So when I do this, folks, it's going up here. Look, it's reducing the reactors. And this reactor here, folks, it turned off. Look, so it's adjusting here. It's reaching 545. To do that, it's operating its equipment. So, to raise the voltage up to 545, what did it need to do? What does it need to do? It had to switch on the capacitor. So here it is. It switched on this capacitor, and now it's switching the reactors, with the goal of reaching 545. So it's here chasing the set point of 545 and switching the reactors and capacitors to reach that value. So now it's switched on this capacitor, switched on another capacitor, and is now switching both reactors. What's being switched here, folks? The reactors through the firing of thyristors, and the delay of the current in these thyristors is the inductive reactive power that we need. So it reached and settled at 545 kilovolts, which is what I asked for. It went up to 23 kilovolts here on the low side of the transformer. And look, now I have this capacitor on, and both reactors with this firing here. And here, folks, I have its B, its acceptance, at 1.98. My gain is 5,500. And here is my total Q. So if I add up my Q here, it will give this value here in MVAR. And now, folks, I'm going to lower it. I'll lower it to 500 and set another set point here at 539. 539. And let's watch the bank working, the compensator working. It's reducing the voltage here, see? Aiming for the 539 that I requested and working here, the capacitor, both capacitors, and the reactor. Here it is. Its control removed this capacitor, understood that it wasn't needed. It increased the reactors here, the firing angle of the reactors. It increased the reactors here and kept this capacitor. And look, it's going up. Little by little now, the voltage to reach 539 is taking steps here. It's settled at 538.39. It's stabilized at that value. And I have 19 amperes in each TCR, and that's how my static compensation works, folks. The goal is to control the voltage at the bus bar. So that's it for today's video, everyone. Take care, and see you next time.